Okay, question 2 is all about the factor theorem. So we're given a function f of x. It says use the factor theorem to show that x minus 3 is a factor of f of x. So the factor theorem says that if we have something like this being a factor, then f of p will equal 0, and therefore p is a root. So what we can do for that is say if x minus 3 is a factor, then we can sub in 3 into the function and get 0. So let's do that. We put in 3 into this function up here. And if we do that, we do actually get 0. Therefore we can say that x minus 3 is a factor. Part 3, B, it says, hence show that 3 is the only real root. So this is a cubic, it should have 3 roots. So we found one of them, so we can say x equals 3 is a root. What are the other 2 roots? Well, if this is the only real root, that means that the other 2 roots must not exist. And we need to try and find a way of finding those roots. One way of doing this is algebraic long division. So we could divide all of that by our factor x minus 3. So we'll do that quickly. X into 4x cubed, 4x squared. That leaves us with 4x cubed minus 12x squared, which is 0. And then continue with the rest. So x into 2x goes twice, which is 2x minus 6, which leaves us with 0. So the other bit is this 4x squared plus 2. So what we can say is f of x can be represented as x minus 3 times 4x squared plus 2. So that's factorised. Now we've seen there's one root from this bit. We've got to show that basically there's no roots from this bit. So we'll take that as a quadratic to solve, basically. And what we could do is we can use the discriminant on this and say if the discriminant is positive, we've got 2 real roots. If the discriminant is negative, then we've got no real roots. So from this we can tell that A is 4, B is 0 and C is 2. Put them into the discriminant, we get 0 squared minus 4 times 4 times 2, and that comes out to be minus 32, which is indeed negative. Therefore there are no real roots for this bit, and therefore there is no other roots to this function. So we can say that there is only one real root. Only one real root, which is 3. Okay, that's it.